6.2 introduces us to exponential functions, and it is one of the main ideas of Topic 6 and of Algebra 1. Your job in this section is to be able to describe and graph exponential functions. You will need Desmos.com graphing calculator open, so go ahead, pause, open that, and let's get started. So, in our very first example, we are going to learn what the key features of an exponential function are. And an exponential function is just a fancy math talk for an equation that has our variable x in the exponent. That's it. That's just when the x is in the exponent. So why don't you go ahead in your Desmos, type in f of x, which is the same as y equals 2 to the x, and see what that looks like. Here are some tips. So first thing you want to know is hitting Shift 6 and getting this little caret key is how you can type an exponent in. Desmos also has like an exponent button if you'd rather look and find that. And what we can see here is we have a curved function now. We do not have a straight line as our graph. We have this curved, in my case it's red line. Oops, can't trace. Whoopsies, here we go. And on your Desmos, you can zoom in and you can zoom out and you can look at it. I'm actually going to take you to my Desmos and we will look at it. 2 to the x graphed. Let's take a gander. And I can zoom out as far as I want, and that remember we read from left to right, it just keeps going up and up forever, exponentially. So over here, I have a little chart for us. If you wanted to find some points on it, you can actually find that in Desmos as well. If you click the gear and then you click the table, it'll give you a table of points. And if you keep giving it more x values, it'll give you more y values. And we could see so many points on this graph, and I just did that from hitting the gear. That's where I found those. And as you're taking notes, make sure you write that f of x is the same as y equals. As you move forward in your math career, we're going to start talking more about functions because you're not just going to learn lines. This is your second thing you're learning, exponential functions. And we call it a function of x because x is our variable, so we call it f of x, which is really just f parentheses x. So here are some things we need to learn about this exponential function. Remember that we read graphs from right to left, so right to left. So this one is what we would call going up as you move from right to left. We'll talk about that in the future. But one major new word that you are going to learn today is called asymptote. And let's dive into this. If we look at our x-axis, and I'm going to highlight it down here in blue, that x horizontal axis, it looks like the function is touching it. It looks like we are touching the x-axis and then we start to shoot up. Well, what's actually happening here is the line is getting closer and closer to the x-axis, but it's actually never touching it. It's kind of just floating right above it, as if there's an invisible line underneath it that we can't touch. Like the x-axis is an invisible line. And we would call that line y equals 0. You'll need to know that. And we're never going to touch it. And that's what an asymptote on a graph is. Asymptote. An asymptote is an invisible line on a graph that you never touch and you never cross the line. Notice the function is not down here below the x-axis and then it comes up. No. It is above that x-axis at y equals 0. So the way that we're going to think about this is you're going to think about this like an electric fence. I don't know if you all have ever experienced like a little invisible electric fence, or if you know that like the dog collars that have like an invisible fence, that's exactly what this is like. And here's our components of why. You can't see it. Just like how on our graph, it's not a line that can be seen. It's not actually there. You can get very, very close to it. And on our graph does. And it's so close that on Desmos, it looks like it's touching it, but it's really actually not. That's something we have to know as humans, that it's not actually touching it. And that's another thing, like an electric fence. You don't want to touch it. You can get really close to an electric fence, but you're not going to touch it and you're not going to cross it. That's why we think of asymptotes like an invisible electric fence. That's one of the key features of this graph, is it has an invisible line that we don't cross. Some other key features of the graph are going to be its domain and its range. So we need to learn what those things are. Domain is how we talk about the possible x values. And our x values are our x-axis, so that's the left to right motion. So how far can we go left? How far can we go to the right? So if we're kind of just tracing this graph and we start at the left and we go to the right, we have the left and we go up to the right, and even though it looks like our graph stops, those arrows tell us that they don't actually ever stop. So when it comes to the x values, like how can we move side to side, it keeps going on forever. It goes on forever to the right. It goes on forever to the left. And it just keeps going and going and going all the way to that negative infinity. Oh, that's an 8. I'm silly. That negative infinity and that positive infinity of the x values, side to side, left to right. It just keeps going and going and going. So when we talk about that for a domain, the way you're going to represent that, you all, is any number. It goes on all the way from negative infinity to positive infinity, left to right. So we write that as all real numbers. So all real numbers. Or a symbol here of a double straight up and down R, because it's like the two L's from the word all and real. That's our all real number symbol. Now the range is just the opposite of the domain. Domain is how the graph can move from left to right. Range is its possible y values, which is how the graph moves up and down, meaning how far we go negative down and how far we go positive up. And so what we know about this graph is it keeps going up, 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 and away. But because of this asymptote that we learned about, this little invisible fence down here, we never cross it and go down. It's never going to come past that invisible line. So the range, when we talk about how it can move up and down, is different than the domain because it is limited. It can only go up. It can't go down. We, on this graph, and when you play around in your Desmos and you zoom in, you can see it, we don't cross this line. We don't cross this x-axis. It doesn't go below it. So since it doesn't do that, we have to identify that when we talk about the cool parts of this function, of this graph, that, hey, it can go up, 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 and away. It can just keep going up, but it doesn't go down. Nope, it doesn't do that. It just stays out forever to the side. So the way we write that, because the range is talking about the y values, we write that just like a little inequality, that the y values have to be greater than 0. And we use greater than because we're not equal to it and we're bigger than it. So one really easy way we'll always write the domain in the range is the domain will always be all real numbers and the range will be y is greater than 0. Make sure you take good notes of this because those are the important key features of every exponential function, not just 2 to the x. You could play around in Desmos and you could change the base of the exponent. You could change that base and you'd still see that we can move side to side, but we are limited up and down. So let's learn more about exponential functions. Now that we know what they look like, they have a very standardized equation for them, where it's y equals some number a times some number b to an exponent x. Y equals a times b to the x, where the a represents our initial amount. Which is kind of just like our starting value. And this b represents our constant ratio. That's a new vocabulary word for us. And the way we describe the constant ratio, because notice this isn't just a straight line, you all. Like we go from 0.25 to 0.5, then to 1, then to 2, then to 4, then to 8, then to 16. So we're not going up by the same amount each time. If you think about it, what's happening between these numbers? How do I go from 1 to 2, 2 to 4, 4 to 8, 8 to 16? You guys, I'm multiplying by 2 each time. That's that constant ratio. That's what makes it a curved exponential line, is it's being multiplied each time. So take a little note. That's what we multiply by each time. Let's use this in practice. Here's an example where they give us a table. It says, what is the written form of the function represented by the table? So we want to write an exponential function. So I'm going to need to use my y equals a times b to the x, where a is the initial amount and b is the constant ratio. So we really just need to know two things. We need to know where the table starts, because that's where our graph starts, and we need to know what we multiply by each time. So let's do the initial amount first. Look at our table, and where does the graph start? Well, it would start at the y value of 4. So the initial amount is 4. And now let's find that constant ratio just by looking at the numbers in our table. It goes from 4 to 12. Let's see if we can identify the pattern. 4 to 12, 12 to 36, 36 to 108, 108 to 324. Take a second to see if you can identify what we're multiplying by each time. Think, 4 times what gives you 12? One way that you can always find this out quickly is to go backwards with division. What is 12 divided by 4? If you want to go backwards, oh, that's 3. There you go. That's what we're multiplying by, because 4 times 3 is 12. So that constant ratio is 3. We are multiplying by 3 each time. 4 times 3 is 12. 12 times 3 is 36. Times 3, it's being multiplied by 3. So we can write our exponential function. We can write y equals, and then we write our initial amount, which is 4. That's going to be a 4. And then we write our constant ratio raised to the x power, which here is the 3. So our answer is y equals 4 times 3 to the x. And sometimes you might see that 3 in parentheses, just depending on how it's being written. So I'm telling you that now. That way if you see it in Envision, it's not a surprise. Let's do another one. This will be our last example for this lesson. Here we are being asked to write an exponential function. So I see those words. So I'm going to think y equals a times b to the x, where a is that initial amount and b is our constant ratio, to describe this sequence of numbers. Okay, my favorite thing to do is our initial amount because that's always what comes first. So the first number, we got 1, 2, like 3, 4, 5 numbers, and the first one is 9. So 9 is our initial amount. So in my answer, I already know I'm going to have y equals 9 times something to the x. And now all we have to do is find out that constant ratio. So our constant ratio is what we multiply by each time. So we want to know 9 times what is 54? 54 times what is 324? This is going to be the same each time. And if you want a quick way to always find that constant ratio, here's a tip. Go backwards with division. So 54 divided by 9. Take the number 2 term, divide by the number 1 term, and that'll give you that constant ratio. And 54 divided by 9 is 6. And one way we can check it is, what is 9 times 6? Is it 54? Yes. What is 54 times 6? Check it. 54 times 6 is 324. All right, cool. That is the number we're multiplying by each time. It's 6. So in my answer, y equals 9 times 6 to the x. Now, main thing to pay attention to is this x is in an exponent. So when you are working on your practice target that you're ready to go start, or you're preparing for a test that you'll take in Envision, you want to make sure you're typing that in as an exponent. You guys are ready? Rewind as needed.